Okay, so this can be a little bit complicated, or depending on at what level you are in your school and how much you have already learned. But don't panic. Just try to remember the most important things. This is what you have to do at this level, because hopefully you are just learning this for fun and you will get interested and learn more as you go along, because at the age that you are likely to be when you are listening to this, as you grow up, you are going to hear more and more about climate change. And whether you become a doctor or teacher or a lawyer or an engineer or a reporter, you may all have to deal with climate in some way, climate change in some way or the other. Okay, so for that purpose, just listen to it, get as much as you can out of it. So what are we looking at? Here we are looking at Earth's surface, and it is tilted at 23.5 degrees to the vertical here in this page, and we are looking at, let's say, just surface winds, and there are names associated with them. There are winds that are curling this way. They are coming from the northeast and heading towards the southwest, and here they are coming from the southeast and heading towards the northwest. Okay, so in the atmosphere, the names of the winds depend on the direction in which they are coming from, and they also depend on historical reasons as to why they are called what they are called. So let's just focus on these surface winds, which means approximately at sea level up to maybe few hundred meters, depending on various things. So they are called trade winds here, which obviously comes from trade, or maybe some other word which has another meaning for trade, like wage. But without worrying about all that, just remember, in the lower latitudes, equator is here. If you don't recognize it, this yellow line here is the equator. So the winds are running into the equator from the northeast and the southeast, so they are called trade winds. They are called northeasterly trades and southeasterly trades. They converge. If winds come together, then what can happen to them? They cannot go into the ocean, so they go up. And when winds go up and they take the air up with them, what happens? Remember from your last chapter that winds go up, pressure is lower from the surface as you go up, so winds expand, they cool, they condense, they form clouds, and they produce rain. So you have a band of rain where the trade winds from the south of the equator and north of the equator come together. Okay, those trade winds have a name that we won't get into, and because of some dynamics of how the earth rotates and how the air is circulating from the low latitudes to high latitudes, you get change in the direction of the winds here. Why are the winds going from low latitudes to high latitudes? Well, approximately, you know that we want to move energy from here to there because there is more energy coming in than going out here. There is less energy coming in than going out here. So we are constantly moving energy from low latitudes to the poles. It's called poleward heat transport or energy transport. So it's happening both in the southern hemisphere and in the northern hemisphere. Okay, so considering all that and the rotational effects, you have what are called westerlies beyond the trade winds. Westerlies means they are coming from the west. So when winds come together, they rise because they have to go up. But if winds are going away from a place like this latitude here, this yellow line here, then if we move the winds this way, then wind has to come in to fill the hole, right? Move water or air this way, then more air or water has to come down. So there is sinking air here, which means there is no expansion, there is no cooling, there is no cloud, so you will have high pressure and no rain. Low pressure and rain bad weather, high pressure, no rain, clear skies, good weather. And again, for other reasons, you have winds coming from the east here. They're called polar easterlies. If you don't understand the details, no need to worry right now. You will learn later again the more details, but just try to remember the winds have these kind of alternating bands: trade winds, westerlies, easterlies. Okay, if we take the average of all the zones, all the longitudes, and see how the circulation is happening from the low latitudes to high latitudes, you will see here that the winds are rising, right? Northeast is coming together, southeast is coming together, and the winds are rising. They're hitting the ceiling that we talked about before. Remember, there is a ceiling here. It's called tropopause. Troposphere is separated from the stratosphere by something called tropopause, where the troposphere stops or pauses, and then you have a stratopause here between the stratosphere and the mesosphere. So remember as much as you can. So the rising air hits it, and then, like the ceiling, it goes in both directions, so towards the poles, towards the south pole and towards the north pole. And for some reason it sinks, it cannot go all the way to the pole, it goes poleward, so from low latitudes towards the poles, and then it sinks and comes back. So you have a cell. This kind of circulation is called a cell. Okay, and remember, rising air, condensation of water vapor, clouds, rains happening here where there is convergence. This is called convergence. Big word. If you don't know, look it up, ask your parents or siblings, or don't worry right now. Okay, so for historic reasons, this is called a Hadley cell. Hadley was the guy who first found the reasons why there are trade winds. So to honor him, we call this a Hadley cell. When airs rise, sink and come back, it's a cell, it's a cycle. So it's a Hadley cell. Similarly, you have another cell here, another cell here, and so on. But essentially all these cells together, they are moving energy from the low latitudes towards the high latitudes constantly. So there is always winds. There are always horizontal winds, there are always vertical winds, there are always winds going from east to west and north to south. Winds just don't go directly from the equator to the pole, they go like this. So you can imagine if you release a balloon, it's probably going to go like this, it's going to go like this, and it's going to go like this. Right? I'm just trying to give you an imagination. So these are the basic structure of the winds. Try to understand as much as you can. Don't panic, don't stress, don't worry if you don't understand all the details. We will come back and look at a few figures like this which show what actually then happens with the winds when the winds blow over the ocean, over ice, over land. They rise in the atmosphere, they make clouds, and then they interact with the greenhouse gases which are in the atmosphere, and so on and so forth. Okay, these are called interactions between the land and the atmosphere, ocean and the atmosphere, between the ocean, atmosphere and land, and so on and so forth. So there is constantly energy being moved around by the winds and by these processes of evaporation, warming, raining, cooling, snowfall, and so on and so forth, because you can even see some penguins here and so on. And you see the mountains with the glacier on top or snow on top. You see a volcano on top here, and of course life, human beings with their cattle and their sheep and goats and the industrial activities and so on and so forth. We refer to, and the ocean also has animals. We refer to this as the Earth system. We'll come back and explain what a system is. You know it, but we'll explain it again. Okay, so very brief introduction to the winds and very brief explanation as to how they are generated It's a complicated story with lots of equations, maths, and computers are needed, and satellites are needed, and balloons are needed, and ships are needed, and so on, to map them, to understand them, and so on. But for your sake, for now, you just understand trade winds, northeast and southeast trade winds meeting to create rain, and then there are westerlies, there are polar easterlies, and so on and so forth. Okay, so I'll come back and discuss the earth system and then add different complications, because when you think about climate and climate change, we are doing many things which is what is causing increases in greenhouse gases and changes in forests and land, from rural areas, agriculture, forests, to urban areas, and so on and so forth. So all these have to be understood to see how energy distribution changes, energy transport changes from low latitudes to high latitudes, how the winds change, how the energy balance, energy budget changes, and so on. Okay, see you in the next podcast.